All right, this is Exponent Rules Part 2. This was done in class on August 15th and 16th. Hopefully you're already comfortable with Exponent Rules Part 1. You may want to rewatch that video. So this worksheet covers 3 exponent rules. The first one is the power rule, which you can see right here. And all this is saying is if we have an exponent raised to another exponent, all we're really doing is multiplying those exponents. And so you can I'm going to go a little in detail with number 1 so you can see why that is. So for number 1, we have 2 to the third to the second power. So what that really is saying is we're doing 2 to the third twice. So that's 2 to the third times 2 to the third. And I could expand these out so we can see really how many 2's we're multiplying. So 2 to the third, I know that's 2 times 2 times 2. Same thing over here, 2 to the third, that's 2 times 2 times 2. We're multiplying those together. So how many 2's are we multiplying? It's 6 of them. So this is really the same thing as 2 to the 6th power. There's a quicker way to get that 6. Again, we're just multiplying our exponents 3 times 2 to get us 2 to the 6th. And for this one, we can actually evaluate this. We know 2 to the 6th, that's going to be 64. You put that in your calculator. All right, for number 2, we're working with variables. I'll expand this one out a little bit so you all can see what's going on here. We have x to the 4th to the 3rd power. So really we're doing x to the 4th 3 times. That's the same thing as x to the 4th times x to the 4th times x to the 4th. And now I could expand this all out again. It's going to be a lot of x's. Or you could even think back to the product rule, which says if we're multiplying terms with the same base, we add exponents. So 4 plus 4 plus 4 gets us 12. And of course, we could get that 12 a lot quicker just by using the power rule that says if we're raising an exponent to another exponent, we just multiply. So 4 times 3 gets us that 12. And so x to the 12th, that is our final simplified answer. Number 3, same deal. I'm going to just get right to the point here using the power rule, though. I'm not going to expand each of them out. That's just taking too much time. So this one, we have an exponent raised to another exponent. So we know we multiply these. So that's going to be m to the 30th. And that 30 is coming from just 6 times 5. Okay. For 4, well, for this one, it's x to the 6th raised to the 0 power. I know anything to the 0 power, that's just equal to 1, right? But let's say you didn't know that. We could still use the power rule, which says we multiply these exponents. So 6 times 0 gets us 0. And then hopefully at this point you would say, okay, anything to the 0 power, that's just going to give me 1. Number 5, so for this one, we're going to use the power rule and then the product rule. So for this first piece, you can see we have an exponent raised to another exponent. So I'm going to use the power rule and multiply those. So that's going to be x to the 5 times 2, which is 10. I'll go ahead and bring down my x to the 4th. And we're not done at this point. We're multiplying 2 terms with the same base. So we're going to go ahead and add our exponents. That's the product rule. So this is x to the 14th. That 14 comes from 10 plus 4. All right, for number 4, I'm going to focus on the numerator first and do the power rule. Since we have an exponent raised to another exponent. That's going to be x to the 4 times 3, which is 12. Still being divided by x to the 8th. And at this point, hopefully you notice that we can use the quotient rule, which says if we're dividing 2 terms with the same base, we can subtract our exponents. And so 12 minus 8, that's x to the 4th power. And again, that 4 just comes from doing 12 minus 8. All right, on to the next. So for this one, in the numerator, I notice I'm raising something to the 0 power. Anything to the 0 power is just equal to 1. I'm going to cross that right out. I know my numerator has a 1. And then in the denominator, we have m to the 10th. And that's really all we can do with this one. Our exponents are positive, like we like them. There's nothing left to simplify here, so it's just going to be 1 over m to the 10th. And then for 6, I'm going to start off by doing the power rule up here. Since we have an exponent raised to another exponent, I know that's going to be r to the 4 times 4, which is 16. And that is being divided by r to the negative third. Now there's a couple different things we could do here. For one, we could say, hey, we can use the quotient rule. We're dividing two terms with the same base. We can go ahead and subtract our exponents. So that's going to be r to the 16 minus a negative 3. And if we're subtracting a negative, that's the same thing as just adding. So this is really r to the 16 plus 3, which is just r to the 19th. And the other way to go about this, and you don't have to do it this way, but if you want to, you could say, well, we don't like negative exponents. So we would have to take this negative exponent and bring it to the top in order to make it a positive 3. And so once that's positive, you can see we have r to the 16th times r to the 3rd. We're multiplying with the same base, we add our exponents. And so 16 plus 3 still gets us that r to the 19th. So that's just a different way to go about it and get the same answer. All right, so I'm going to move on to power of a product rule. It's very similar to the power rule. The only difference really is that we have multiple variables inside the parentheses. Sometimes it's a coefficient in a variable or a coefficient in multiple variables. Doesn't matter, it's going to work the same way. And so what I like to think of it as is we're taking this exponent and applying it to whatever is inside the parentheses. So in this case, we're applying that a, that exponent of a, to both the x and the y. And so that's how we get x to the a, y to the a. So let's look at an example so we can understand this better. For number 1, we have 2x to the 3rd power. So I have to take this exponent of 3 and apply it to both the 2 and the x. So this really becomes 2 to the 3rd, x to the 3rd. All right, and we can clean this up just a little bit. 2 to the 3rd, that's 2 times 2 times 2, which we know is equal to 8. This is really 8x to the 3rd power. Moving on to number 2. So now on the inside here we have a coefficient, a variable of x, a variable of y. It works the same way that we have to take this outside exponent and apply it to the 5, the x, and the y. And so be careful here, because if we're raising an exponent to another exponent, like we are on the x and the y, we're going to multiply those exponents. And you can always think of 5 as having an exponent of 1. Remember, if we don't see an exponent on it, we know it's actually just equal to 1 up there. So this is going to be 5 to the 2nd power, x to the 3 times 2, which is 6, and then y to the 2 times 2, which is 4. And again, we can clean this up a little bit. We know 5 squared, that's 5 times 5. which is 25. So I'm going to change that to a 25 and then bring down my variables, x to the 6th, y to the 4th. Number 3, we're working with some negative numbers. I'm going to apply this 3 to the negative 3 and to the x. So this is really negative 3 to the 3rd power, x to the 6th power. And that 6 comes from 2 times 3. All right. And so negative 3 to the 3rd power, that's the part we can simplify here. So negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. You may have to think about that one for a second. And then I'll bring down my x to the 6th. Okay, moving on to 4. Couple different ways you could do 4. I'm going to stick to what we've been doing and use the power of a product rule and take this negative 1 and apply it to the x, the y, and the z. And so, I'm going to multiply all of those exponents. So this is going to become x to the negative 2, right? 2 times negative 1, y to the negative 2, z to the negative 2. And remember, we can't have negative exponents. And so the way we handle those is we're going to move them down to the denominator. And by doing that, it makes those exponents positive. And so what's left in the numerator is just a 1. And then in the denominator, we're going to have all these variables raised to the positive 2. So it's x to the positive 2, y to the positive 2, z to the positive 2. And so that's our final answer right there. And the other way you could think about this is if we're raising this whole grouping right here to the negative 1st power, well, we can't have negative exponents, and so we have to move this whole thing down to the denominator. That's just another way to think about that. So by moving all of this down to the denominator, you get 1 over x squared, y squared, z squared. Okay. Number 5, I'm going to go ahead and use the power of a product rule for the numerator. I'm going to take that 2 and apply it to the x and the y. So now in my numerator I have x to the 3 times 2, which is 6, y to the 4 times 2, which is 8, and that's still being divided by x squared, y cubed. And hopefully you can see at this point we can simplify this using the quotient rule. If we're dividing two terms with the same base, we can just subtract our exponents. So this is x to the 4th, y to the 5th. The 4 comes from 6 minus 2, and then the 5 comes from 8 minus 3. And so that's our final answer. And these are being multiplied. If you don't see an operation in between, we assume it's multiplication. If you would like, you can still put that dot, though, to indicate multiplication, too. Okay, number 6. So I'm going to leave the numerator alone. Nothing I can do there, but I'll move down to the denominator. And I'll go ahead and use the power of a product rule. I'm going to say, okay, that negative 1, I have to apply it to the m and the n. So this is really 1 over m to the 2 times negative 1, which is negative 2. And then n to the 4 times negative 1, which is negative 4. And remember, we don't like negative exponents, so to make these positive, we have to move them up to the numerator. And so now in the numerator we have m to the positive 2, n to the positive 4. Technically our denominator, there's just a 1 left. We don't have to write the divided by 1 because anything divided by 1 is just itself. So I can really just have my answer be the numerator, which is m squared n to the 4th. All right, for number 7, I'm going to go ahead and apply that -1 to the r and the s. So we're going to multiply these exponents. That gives me r to the positive 5, s to the negative 4. And this is almost simplified, but again, we don't want to leave negative exponents. So I'm going to have to bring this down to the denominator. R to the 5th can stay right where it is because that's a positive exponent. We don't have to move those around. So our final answer, we have r to the 5th in the numerator, and now s to the positive 4 in the denominator. Remember, we can't take this any further. We can't combine terms with different bases. Keep that in mind. Okay, so number 8 is a really good problem here. This is probably a typical quiz question you may see. So I'm going to start by taking care of this 4 using the power of a product rule. I'm going to apply that 4 to the x and the y. We're multiplying exponents, so this is x to the 3 times 4, which is 12, and y to the 4 times 4, which is 16. And that's all over x to the 10th, y to the 17th. So now I can use the quotient rule that says if we're dividing two terms with the same base, we can just subtract our exponents. So this becomes x to the 12 minus 10, which is 2, and then y to the 16 minus 17, which is -1. This is definitely a multi-part problem because there's one last thing here. We can't have a negative exponent, so I have to take this and bring it down to the denominator to make that -1 a +1. X to the 2nd, that's going to stay in the numerator because it has a positive exponent. And then y to the +1 will be in the denominator. And technically, I don't even have to put that exponent of 1. If it's not there, it's still understood to be raised to the 1st power. Okay, on to the last rule here. We have power of a fraction rule. Again, these are all really similar, all very much related. So this one is saying if we have a fraction raised to a certain exponent, we have to apply that exponent to the numerator and the denominator. So x over y to the a power, that becomes x to the a over y to the a. So let's look at an example here. We're starting easy with some actual numbers. So we have 2/3 raised to the 3rd power. So I'm going to take this 3, exponent of 3, and apply it to the 2 and the 3, the numerator and denominator. So this becomes 2 to the 3rd over 3 to the 3rd. And we can clean this up a bit. We know 2 to the 3rd, well, that's equal to 8. And then 3 to the 3rd, that's 3 times 3 times 3, that's 27. Can't simplify this, so that's going to be our final answer. All right, number 2. Again, we have a fraction. Now we're working with variables, but it's still a fraction raised to an exponent. So I'm going to go ahead and apply this to the numerator and to the denominator. So this is really x to the -4 over y to the -4. Now remember, we don't like negative exponents. And so in order to fix that, we have to take this term up here and bring it down to make the -4 positive. And then we'll take this term down here and bring it up to make that -4 positive. It's like we're swapping them, we're flipping it. And so then that will be y to the +4, now that we've brought it up, over x to the +4, now that we've brought it down. And so that's our final answer there. Okay, for 3, we're kind of using power of a product rule and power of a fraction rule. I'm going to take this 2 on the outside, and really I just have to apply it to everything inside. I have to apply it to the x, to the y, and even to this 4 down here. So this becomes x to the 2 times 2, which is 4, y to the 3 times 2, which is 6, and this is over 4 to the 2nd power. So the only thing we can do here to simplify this more would be the 4 squared. And so we know 4 times 4 is 16. And then I'll just bring down this x to the 4th, y to the 6th. Okay, number 4, be careful on this one because we have to apply this 3 to everything. It goes to the 4, to the x, and to the y down here. So it's going to be 4 to the 3rd, x to the 3rd, over y to the 9th. And this 9 comes from doing 3 times 3. Remember, if we're raising an exponent to another exponent, we multiply. And so the only thing we can clean up here is this 4 to the 3rd. You may want to put that in your calculator, but that's 4 times 4 times 4, which gives us 64. And then I'll bring down my x to the 3rd and y to the 9th. Okay, on to number 5. Let's see if that'll focus. Okay. So same process here. I'm going to take this exponent of 3. I'm going to apply it to this -3 into my denominator. So this is really -3 to the 3rd power over x to the 12th power. That 12 is coming from the 4 times 3. So I think from above we said -3 to the 3rd power. That's -3 times -3 times -3. That gets us -27 over x to the 12th. And I got a lot of questions about do I need to move this -27 down to the denominator to make it positive? And the answer is no. We're okay with negative whole numbers like this. What's not allowed is the negative exponents. And so this isn't an exponent, it's just a regular number, so it's allowed to be negative. It will stay right there. Okay, number 6. Same process. I'm going to take this exponent of -1 and apply it to the m, the n, and even the m down here. So this becomes m to the +2, right? -2 times -1. N to the -4 comes from 4 times -1 over m to the -1. So now we're dealing with some negative exponents. A couple different ways we can go about this, but I'm going to go ahead and take this n to the -4 and I'm going to bring it down. And by doing that, it makes our exponent positive. And then this m to the -1, I'm going to bring up. And by doing that, it makes the exponent positive. So now we have m squared. I'm just bringing that over here. Once I bring this term up, it's going to be m to the +1. And this is over n to the now +4. So I move this one up to make the 1 positive. I move this one down to make the 4 positive. Last thing we can do is use the product rule to simplify these. If we are multiplying two terms with the same base, we're going to go ahead and add exponents. So m to the second times m to the first, that's really m to the third, right? 2 plus 1, and that's still over n to the fourth. All right, number 7. I'm going to take this exponent of 2 and I'm going to apply it to the a in the numerator, and then the a in the denominator and the b in the denominator. So this becomes a to the 14th, and that 14 is from 7 times 2, over a to the second, right? Because technically this a right here has an exponent of 1 when we don't see anything. And so 1 times 2 gives us that 2. And then b to the negative 6, right? Negative 3 times 2 gives us negative 6. Okay, so I see this negative exponent staring at me, so I'm going to take that and bring it to the top to make it positive. So now we have a to the 14th, b to the positive 6, now that I brought it up, over a to the second. And we can still clean this up a little bit. We can use the quotient rule, which says if we're dividing two terms with the same base, we're going to subtract the exponents. So 14 minus 2, that's a to the 12th. And I'll bring down my b to the 6th. So that's our final answer. These get a little harder as we go along here. And so finally we have number 8. Same process. I'm going to take this exponent of 3, apply it to the 2 in the numerator, and then the x and the y in the denominator. So this is 2 to the third over x to the 15th. The 15 comes from 5 times 3. And then y to the negative 15th. The negative 15 is from negative 5 times 3. And so I notice this negative exponent. I'm going to have to bring that up here to make it positive. And then I'll go ahead and evaluate 2 to the third power. That's 2 times 2 times 2, which gives me 8. I'm bringing up y to the negative 15th, so that's y to the positive 15, and then we'll just have x to the 15th left in the denominator.